Defining color using X, Y, and Z notation can be confusing and misleading. That's where the other ways to access this same information, but with different names. Okay, so X, Y, and Z can be called RGB and ST and P. Okay, so that explains why the variable was called ST. Kind of. I mean, S and T are still not that great names. You can also access the data in a vector by using the index position. Okay. These different ways of pointing the variables inside a vector are just nomenclatures designed to help you write clear code. The flexibility embedded in shading language is a door for you to start thinking interchangeably about color and space coordinates. And the great feature of vector types in GLSL is that the properties can be combined in any order you want, which makes them easy to cast and mix values. Called Swizzle. Okay, that's pretty nice. Might not be used to picking colors with numbers, that's fine. Here are templates that I use. Oh, so this is RGB and RGB with alpha. And you can mix colors. Finally, with the mix function, which is a linear interpolation between 1 and 0, yeah. Okay, so this should be fairly easy to run. I guess I'd be pretty surprised if this didn't run, given that the other stuff already did. Unless there's a yeah, an error because I didn't use a uniform. Nope, undefined variable uTime. Oh, because I'm still setting it. Wait, the time should be used here. Where's the time used? It's taking the sign of uTime. So there was some bug with this. Key error U resolution. Dang, I messed something up. And I don't know what. Wait, how did the thing before work? So this runs, but this... What did I do? This seems like fairly simple shader. A key error from here, trying to set the U resolution. But it's listed as a uniform here. Now I'm confused. Man, and it was working so well. I'm passing the resolution here, so what's the difference? I'm going to try replacing these functions one by one. Okay, so now I'm just going to bring in the main function. There's the new main function, and this is going to need the colors. I am so confused. Oh, it's because U resolution isn't used. And because it isn't used, you can't declare it. Or you can't set it. Great, okay. Alright, I think that's pretty straightforward what this is doing. Great, okay. Alright, I think that's pretty straightforward what this is doing. Now we should remove the extra code here. This is just modulating the time according to the sinusoid, taking the absolute value so that it's non-negative, and then it's interpolating between these two colors. It's fairly straightforward. Make a better transition between colors. I guess you can always do different functions here. Can you just do exp like this? Well, oh. I guess the exponential is just going off into infinity. So I'd want something like a cosine. But this is going to turn negative, which also it isn't supposed to do. Whatever. That's a variable type that matches the first two arguments in our case of vec3. This allows us to control the mixing percentages. Like in this example, you can hook the transition to the normalized x-coordinate and visualize that with a line. All the channels will go along the same line. Okay, so I'm going to try to run that. If I can do it without crashing. I feel like this is going to crash. Because there's so many variables and one of them is going to be unused or something like that. And it's just going to crash. U resolution is used. U mouse is not used. U time is also not used. So I guess I can't do this. Or this. This might work, I don't know. Oh, nothing appeared. Why would nothing appear? What did it do here? Uncomment lines 26 and 27. Oh, this is setting the certain colors of some of the channels. That's a nice effect. But why is it not working here? Oh, I didn't pass the resolution. Perfect. Man. When these have errors, they just don't show anything. Okay, but this is moving according to this line. Oh, this is mixing. This is mixing the colors in the background according to these graphs. You could use a validator maybe. Yeah. If there's something that just told you, like, hey, this variable isn't used, or hey, this variable you're trying to use but it doesn't exist, that would be pretty helpful. But none of that comes out of the box, I guess. You probably recognize the 3 shaping functions. Yes, I do. Play with them? Nah. Although it would be kind of cool to modulate the sign or something like that. Like if this was... If I did this plus the U underscore time, and I update the time on each frame. That's kind of neat. But anyway. Compose a greeting that resembles this sunset. Nah. Animate transition between a sunrise and a sunset. Can you make a rainbow? Use the step function to create a colorful flag. Hue saturation bright animate transition between a sunrise and a sunset. Can you make a rainbow? Use the step function to create a colorful flag. Hue saturation brightness. Can't talk about color without speaking about color space. You've been using the RGB channels. Can use hue saturation and brightness. And so there are these functions for that. By mapping the position on the x-axis to the hue and the position on the y-axis to brightness, we obtain a nice spectrum of visible colors. The spatial distribution of color can be very handy. It's more intuitive to pick a color with HSV than RGB. If you say so. I wonder what this shader toy link is. Okay. So if this works, I guess this will be the second shader toy, the shader that I've managed to successfully run. Alright, it crashed. But I probably know why it crashed. Because I'm not using this time variable. So that would definitely... Yeah, okay. Cool, I did it. Those functions... Going from RGB to HSV, I always called it HSV. These functions are crazy. I'm not going to try to reverse engineer those. Then you can do it in polar coordinates. Obtain the angle and distance from the center of the billboard to the pixel coordinate. Oh, there's a length function. And arc tangent, which I'm not sure why that would come in useful. If you're wondering, there are more geometric functions besides length. Distance, dot, cross, normalize, face forward, reflect, and refract. GLS has special vector relational functions such as less than equal to, blah, blah, blah. Okay, now I have faith that this will work. After we've come this far, we've run this many shaders. I think this one will work, but not if I pass the time, which I think I'm not doing. Great. I wish I could make this a square, but if you resize this, it doesn't do what you think it'll do. But it's pretty nice that you can get the center this easily and the angle. That's why I need the arc tangent. Arc tangent y over x and then radius length to center. Why times 2? Okay. Okay, map the angle, negative pi to pi to the hue. Okay, great. So that worked too. I learned a bit more about how shader coloring works. Modify the polar example to get a spinning color wheel. It shouldn't be terribly difficult. Maybe if I do this and I put the time like I guess I just added to angle, like it's just an angle plus equals. Great. Okay, cool, cool. Use a shaping function to gather the conversion function from HSB to RGB to expand a particular hue and shrink the rest. Nah, I'm not gonna do that. If you look closely at the color wheel used on color pickers, there's a different spectrum according to RYB color space. For example, to that. If you look closely at the color wheel used on color pickers, there's a different spectrum according to RYB color space. For example, the opposite color of red should be green. Looks like it's kind of green. But in our example, it's cyan. Oh. Can you find a way to fix that in order to look exactly like the following image? Hint, this is a great moment to use shaping functions. Probably could, but I'm not going to. Go back and take a look at the functions in the previous examples. You'll notice in before the type of arguments. Oh, in is a qualifier. In this case, it specifies that variable is read-only. Yeah. I've had to deal with these actually to get this working. But the shader code uses this directive on its own. You'll see it's also possible to define arguments as out or in-out. In-out is conceptually similar to passing an argument by reference, which will give us the possibility to modify a passed variable. That's pretty nice. We have all the elements to make cool drawings. The next chapter we'll learn how to combine. Cool. Alright. That was fun. Learned a fair bit about shaders. Got shaders running in Manim. That's really nice. GLSL Lang validator can do a validation and spur 5 conversion. Maybe that'd be worth looking into. GLSL. Does it just like take a string? Okay. Alright. But for now, I'm going to do a raid. Takes a file at least for the CLI tool. Gotcha. That could be useful. I should probably learn how to raid. Just go to the science and technology channel and see what's going on. A bunch of these people are way bigger than I am. It'll be someone who speaks English. I'm gonna get that right this time. We can raid this person. Elegance Fox. Quanta.frag extension. Gotcha. Okay. Say hi. I'll see you guys in the next stream. Get in the Discord if you're not already in the Discord. I will see you guys. Oh. Mm-hmm. 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 Mm-hmm.